let's do the 5.6 homework. So we are looking at square roots and cube roots, you guys, with some transformations mixed in, okay? I think we should start by reviewing transformations. So if I have, I'm gonna call it, I'm gonna make it look like a square root because that's what we're doing right now. Let's say we have like a f of x equals, and then we have a square root. So whatever happens, you guys, inside the radical, and this might be square or even cube, or whatever. So I'm gonna put like a little n here to say that this could be a square root, a cube root, or whatever. Whatever happens on the inside is happening to x. Actually, I don't like that. I don't want it to look like it's divided by anything. So everything here is a horizontal transformation. So if I have like an x plus or minus something, I'm gonna go with a C right there. It's a horizontal shift or translation. C times C units to the, it's gonna be to the left if positive, and it's gonna be to the right if it's negative, okay? So that's that. And then we also have a possibility of having like a negative in there. So that would be that negative would be a horizontal reflection. So that means we would flip over the y-axis if there's a negative there. And note the parentheses, you guys. If that negative isn't factored out, it will mess up your shift. So it should look like that. Okay, now let's look at what could be in the front. In the front, we could have like an a value. This a value would be a vertical, and I don't know if it's gonna go this in depth, but we learned it before. Oh no, it does. There it is right there. I see it in number 3. It's gonna be a vertical stretch or shrink. Now I remember with parabolas, a stretch looked narrower and a shrink looked wider, so people mix them up. With these, they actually look how they're supposed to look, okay? So a vertical stretch is gonna look stretched, a shrink is gonna look shrunken? I have no idea. Anywho, here's how it goes. If A is bigger than 1, it's gonna be a stretch. And it's gonna be a shrink if it's like between 0 and 1. So like a 1/2, a 1/3, something like that. And lastly, I like to separate this from A. There could be a negative in the front. And if there's a negative in the front, that's a vertical reflection. And it's over the x-axis, okay? And then the absolute last thing is that we could have a plus D. This right here, D, is a vertical shift. So we would be moving D units up if positive, and D units down if negative. And you might be wondering where B is. B would be a horizontal stretch or shrink, which I'm not gonna get into it unless we gotta. Do we gotta? Yeah, I don't know. Yeah, kind of. We'll see. We'll see where it goes, all right? There might be a little b right there, and if there is, I'll come back and add it. So that's that, okay, you guys? So please note, everything that was inside the root with x, inside the radical with x, was a horizontal something. And everything that's outside of it is vertical, 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 okay? And then everything inside is horizontal, horizontal, okay? Cool. So that's our little review. Now let's go put it to use. The function, should we keep it so we could see it? At least for the first one. The function g of x is a transformation of f of x. What is the equation of g of x? So we want to look at f of x. That's our original one. And I like to look at where it starts. So that point where it just appears to start out of nowhere, that has moved 1, 2 to the right. And it has gone 1, 2, 3 up. And then there's been no reflection because it's all oriented exactly the same way. And there's no stretch or a shrink because from that first position, it just goes up 1 over 1. And so does this one, up 1 over 1. So they're exactly the same size. So this is all that's happened. So 2 to the right would be a minus with the x. So a minus 2. So not that one and not that one. And then 3 up is a plus 3 at the end. So it's going to have to be C. Okay? So remember this. Okay. Let's look at these. Change the equation so that it matches the graph. Ooh. Let's see what we're looking at. I'm looking at a cube root that begins at -1, -2, -3, -4. So it's gone 4 left. And it's also gone down to... What happened? What did I do? Make it go away. Okay. And that's it. You guys, I can tell there's been no stretch or a shrink or anything if it goes up 1 over 1. That's how I can tell. Okay? From right here, if it goes up 1 over 1, there's been no stretch or shrink. And then it has this orientation. This is the standard orientation. So there's also been no reflections. All I need is for this to be x plus 4, because 4 to the left means plus, with x. And 2 down means minus 2 out here. Okay? All right. Let's look at the next one. Okay. Let's see what we got. So our standard square root function begins at 0, 0. This one is up 1. Actually, that's a lie. You gotta reflect first. Then it's up 2. Ooh, so tricky. Love it. Okay, let's start. Let's start over. Let's look at what the original function would be. Just a normal old square root of x, okay? Square root of x would be at 0, 0. And then it would be at 1, 1. Because square root of 1 is 1. So 0, 0, and 1, 1 is the standard graph. It goes the same with the cube root function as well. And then after that, if I were to put a 4 in for x, I would get 2. And this is the shape and orientation and everything of my regular square root function. So let's start seeing what happened. And please remember that when we are transforming, when we transform, shifts must be last. Okay, because of PEMDAS. Shifts are addition and subtraction. And PEMDAS puts addition and subtraction at the very, very end. Okay, so over here, the first thing that must happen to this is the vertical reflection. I can tell this flipped upside down. So a vertical reflection would flip it to be like this. I'll do it in green. Okay, now that it's facing the right way, oh, it's still gone up 1. So I think I made it too complicated in my head. Doesn't matter though, we're still doing this the right way. So now, the other thing to take note of, other than the fact that we've gone up 1, is that this one is stretched. Now I'm gonna erase everything so we can see it. Do you see it? Normally, from this point, we just go up 1 over 1. Now this one's flipped upside down, so it would be down 1 over 1. But it's not going down 1 over 1. It's going down 2 over 1. That means we have stretched. We have ourselves a vertical stretch, and it is by a factor of 2. And the way I know that is that on the standard square root graph, on the standard square root function, here, let's go back and look at it right here. You start and then you go up 1 over 1. If our stretch factor is 2, we'll go up 2 over 1, and it'll look like this, which is what we're looking at in that problem, except that it's flipped upside down, so it kind of does this kind of a thing. So if it goes up 3 and over 1, then the stretch factor would be 3. Up 1, 2, 3 over 1, then it would be a vertical stretch with a factor of 3. Okay, so let's go back. All right, so now we put all this together. So I've got myself a factor of 2, a vertical stretch, and a vertical reflection. So I need the negative for the reflection, I need the 2 for the stretch, I need my square root of x, and then finally, remember from here, our reflected graph has moved up 1. Oh, we already have that, up 1. So that's what that graph should look like. That's what that equation should look like. Okay, let's keep going. Let's take a look. This one, okay, originally would have been at 0, 0, and then up 1 over 1, and it would have this shape, right? This one has the same orientation still, so no reflections. It has moved left 1, but it is for sure stretched, okay? So when it goes over 1, instead of only going up 1, this one goes over 1 and up 1, 2, 3, 4. So stretch, vertical stretch by 4. So this is going to be a 4 on the outside of the square root. So this is what they're messing it up. They did it in the past too. I didn't really point it out. But they put that negative inside with x, making it a horizontal reflection. That would have been if it looked like that. If it went that way. But no, this one flipped downward, so it's vertical. So they should have had the negative on the outside. So these are the little mistakes that they're making. They're putting things in the wrong places. So a vertical stretch goes out there. And then left 1 goes inside. Plus 1. That part looked sort of okay. Technically, the 4 would be factored out. This is a shift of 1/4, but we don't need to get into it that far. Okay. Now we're going to write a function that would capture all these stars. So I'm just going to put a line through the stars and try to come up with that function, because it works in Marble Slide if you do that. So we go up 1, 2, 3. We need to go up 3. We definitely need a horizontal reflection. So if we do a horizontal reflection and we go up 3, and from here, if we begin right here and go up 1 over 1, that means no stretch. We don't need any stretching. This is all we need. So I only need a horizontal reflection, so a negative on the inside. Sorry, I got paranoid about something. Okay, a negative on the inside, and then we need to go up 3, so plus 3 on the outside. Okay, and looking at this looks fantastic. It looks like it just goes up 1, 2, 3, 4. And then it does the same exact thing that it's currently doing from there. Up 4. That's all I see. Up 4. So it's our cube root function, just up 4. All right. This is a good place, you guys, to like keep track of what your standard cube root and your standard square root look like. Okay, let's see what's going on here. Here, we've got ourselves a reflection. Now, there was a slide in our assignment that pointed this out, that when it comes to cube roots, a vertical reflection and a horizontal reflection are the same thing. It doesn't matter. That's because negative cube root of x is the same as negative cube root of x. They're the same. Watch. Cube root of negative 8 is the same as negative cube root of 8. Cube root of negative 8 is negative 2. Cube root of 8 is 2 with a negative in front. It's the same exact thing, you see? That's why they're the same. So in this case, you have the choice. Call this a vertical reflection. Call it a horizontal reflection. I don't care what you do. Just make sure you put a reflection somewhere. But in addition to the reflection, we have also moved to the right one. Yep, right one. So I'm going to do a cube root of x minus 1, and then I'll just throw my reflection on the vertical because it's simpler. Because if I did make it horizontal, you guys, I would have to write it as a negative parentheses x minus 1. Okay? Either of these is okay. All right. Here's a graph of cube root of x. Write a new function that goes through point 1, 2 for the transformation of f of x. Oh, I see. They're going to give me different stuff. So if I have m of x is a vertical and horizontal translation to go through the point 1, 2. So over here, I wanted to do a vertical and a horizontal translation. So basically, I got to go up 2 and right 1. To get both a vertical and a horizontal. I could have gone through that point just going up 1. But then I wouldn't be doing both of these translations, and that's what they want. So cube root of x minus 1 plus 2. Okay, now they want me to go through that point, but only using a scale, meaning a stretch or a shrink. All right, so if instead of going up 1 over 1, I go up 2 over 1, that's a scale by a factor of 2. So I can just write 2 cube root of x. I don't like the way I wrote that 2. It's supposed to be like that. Okay, and then now we want there to be a reflection and a translation. So a reflection, no problem. That's going to make us go like this, though. We'll be going this way instead. So then now, if I do the reflection, then I must translate 1, 2, 3 up. Three up with a reflection. Okay? And then spiral review. Here are 3 functions. Let's do it, you guys. You guys tend to get rusty on this stuff, and it's super important. So let's definitely get on that. Remember, you guys, please. This does not mean P times 4, Q times 5, R times 0. No, it does not. This means P of 4. P of 4 means, P of 4 means go to P. What's happening? Go to P and plug in 4 for X. Remember, the number inside the parentheses is X. So here's P. Here's what it equals. And I'm going to plug in 4 where X is, just like that. And then it's plus. Now Q of 5 means go to Q and plug 5 in for X. So that's this with a 5 where X is. And now we simplify this. So this is negative. Square root of 4 is 2. Plus 5 plus 4 is 9. And square root of 9 is 3. And all of this equals 1. P of 4 plus Q of 5 ultimately equals 1. All right. Over here, R of 0 means go to R and plug 0 in for X. So that's the square root of 3 times 0 minus P of 16 means go to P. P is a negative square root of X, but instead of X, I'll drop in 16. And this negative and negative do become a plus. And this is 3 times 0 is 0. Square root of 16 is 4. And square root of 0 is 0. And 0 plus 4 is 4. So all of this ultimately equals 4. And then look at here. We're multiplying P of 1 times Q of 0 times R of 12. So P of 1 times Q of 0 times R of 12. Square root of 1 is 1. With the negative makes it a negative 1. 0 plus 4 is 4. Square root of 4. 3 times 12 is 36. This is square root of 36. And then this is negative 1 times 2 times 6. Because square root of 4 is 2. Square root of 36 is 6. And so this all multiplied together gives us a negative 12 as the answer there. Okie doke. There we go. The 5-6 homework with a detailed review of transformations.